In the last section, we updated our multi-client image, and then we pushed the result off to Docker Hub. We're now going to move on to step 3, which is to somehow convince our deployment to recreate or otherwise update all of our pods with the latest version of that multi-client image. Now, unfortunately, step 3 right here is very challenging, and there's not a very good solution around it. Now, that might be very surprising, but I just want to be very clear with you. In the world of Kubernetes, convincing a deployment to recreate our pods with the latest version of an image is not the easiest thing in the world to do. So inside this section, we're going to take a look at why this is challenging, and then we're going to look at a couple of different ways to solve this problem. Now, before we start talking about why this is challenging or any of the solutions, I want to very quickly mention to you that on the GitHub page for the Kubernetes repo, you can go to the issues board and reference issue number 33664. To get to this issue in particular, you can just type that issue number directly into your address bar. This is an entire issue with a ton of different conversation going on here, talking about how challenging it is and suggesting different ways of convincing your deployment file to somehow update all the pods that it is managing. So I do recommend maybe taking a quick glance at this issue thread and getting a better idea of some of the root causes here and some of the different ways of solving the problem. All right, so let's take a look first at why this is so challenging to get a deployment to update the image that is being used by all the pods that it manages. I want to first remind you that in order to update any object inside of our Kubernetes cluster, we make a change to our deployment file, and then we send the deployment file off to the kubectl command line tool with something that looks like this right here, right? We do the kubectl apply. Now, the issue that we have right now is that inside of our deployment file, there's nothing inside of here that says, hey, I want to use some particular version of our multi-client image. So when we send an update to multi-client off to Docker Hub, when we make our updated version of that image and we send it off, there's nothing that we can kind of turn back around to this file with and say, hey, I want you to now use like the latest image. Now, the reason that's such a big deal is that if we try to take an unchanged configuration file and apply it with kubectl, if there's no changes in the configuration file, then kubectl apply is just going to flat out reject the file. Let's try that out right now. Remember, we've already applied this file and we've made no changes to it since we last authored it. Okay, or excuse me, since we last applied it. So back at my command line, I'll do a kubectl apply -f client deployment.yaml. And then when I run this command, it's going to tell us that the file is unchanged. And so the entire file, the entire apply command is just flat out rejected because the config that we're trying to upload is identical to the last config we put in place. Now, when you put this file up, it's unchanged. That means totally rejected. So there's nothing inside that process that says, oh, we should probably go and see if a new version of this image is available. That does not occur. At no point when you try to re-upload or reapply that config file, it does not try to see if a new version of this image is available. And so the entire apply command just flat out rejected. That's why this is such a big issue. Okay, so with all that in mind, we're now going to look at a diagram that's going to lay out 3 possible solutions that we could use to get around this issue. So none of these solutions are really that great, I'll be honest with you. None of them are really that good. They're kind of the best of a bad situation. Okay, so here's the first option we can use to get our deployment to update with the latest version of that image. We could manually delete all the pods that are managed by that deployment. Now, when we manually delete a pod that is managed by a deployment, the deployment is going to very quickly notice that the pod is missing, and it's going to attempt to recreate it automatically. So in other words, if we go over to our terminal right now and do a kubectl get pods, and then attempt to delete this pod right here, the deployment will very quickly notice that it has a missing pod, and the deployment will recreate this thing automatically. So our hope there would be that when the pod gets recreated, hopefully it would pull down the latest version of that image. And so we could use that as a means to recreate our pods with the latest image, or excuse me, latest version of some particular image. Now, why would we not do this? Well, as you might guess, deleting pods seems like a really, really silly situation or a really silly solution. There's so many things that could go wrong with this approach. In a production environment, we could very easily accidentally delete the wrong set of pods. Totally possible. So if we delete the wrong set of pods, who knows what type of bad situation we would be in. In addition, if we manually delete all of our pods related to one very particular aspect of our application, let's imagine that maybe this is the pod that serves up all of our web traffic. And so if we delete all those pods for a very brief period of time, any user trying to access our application would be trying to get at a pod or get at a container inside there that just doesn't exist. And for a very brief window, our users would essentially not be able to access our application entirely. And so everything about deleting these pods just kind of seems like a bad idea. Okay, so let's take a look at the second possible solution. All right, so I want to give you a quick reminder on tagging of Docker images. When we tag an image, we put down usually our Docker ID, a slash, and then the repository or project name. Now, one other thing that we can optionally put in here is a colon and then a version for this image. And so we could put in something like, v1, and then maybe the next time we build the image, we would increment it to v2 or v3 or v4 or v5 or whatever it is. So as a possible solution to this problem, we could decide to tag our images with real version numbers and then specify that version inside the config file. So in other words, when we build our image back over here inside of, run our Docker build command and tag the image, we could put on a version number like v1, v2, v3, or v4, whatever it might be. We then push that tag up to Docker Hub, and then inside of our config file, we could append on that v1, v2, v3, v4, or whatever it is. Now, when we change the config file with a version number like this is an actionable change to our config file. So if I put on here v4 and then save the file and then rerun that kubectl apply command, that is detected as a very real change to our config file. And so the config file would be accepted by kubectl apply because we are specifying a completely different image version. Our deployment would then use that new image version to recreate and update all of the pods that it manages. So this would be one possible solution. Now, the downside to this approach is that it really adds in an extra step to our deployment process, and it's definitely not a very friendly step. Because think about what we would have to do. We would essentially have to make sure that anytime that we build our images, we would have to append on some version number over here, like 1, 2, 3, 4, 5, whatever it is. And then we would have to go over to our configuration file and put the exact same version number inside of here as well. So we would have to remember the current version and somehow insert that number inside of here. And that's definitely a non-trivial step to add in here. Now, one quick workaround to that you might imagine if you're a little bit savvy, you might think, okay, well, if it's such a pain to get the version number in here, maybe we could get like an environment variable or something like that that would carry the version of that image. So when we build the image, we could store the version number in an environment variable and then reference that environment variable inside of our file. So we could do something like, client version. Well, unfortunately, we are not allowed to use environment variables inside of these config files. So that solution kind of goes out the window as being an easy workaround. So specifying the version, it definitely would work, but it adds in that extra step of having to assign a version number when we build the image. And then we also have to make sure that we somehow inject that version number into the file. We literally would have to inject the version number through some type of templating process. So that definitely doesn't seem like it's a very good version or a very good solution as well. All right, so now the last thing that we could do is we could use an imperative command to update the image version that the deployment should use. So this is somewhat similar to the last step. It's saying that when we build our image, we would still append on a version number, so like v1, v2, v3, whatever it is. But then rather than updating our config file, we could immediately run a command after building our image that says to Kubernetes essentially like, hey, Kubernetes, go find my client deployment and update the version number, I don't know, I'm just making up this command here, update version to v1 or something like that. Now, this is very similar to the previous step in that we are still going to tag our image with a version number, but the downside to this approach is that it's using an imperative command, and it's essentially completely skipping over our config file and keeping our config file up to date with the state of our cluster. So all three of these steps seem like, bad solutions. They don't really seem like they're the best things in the world to solve this problem. I think without a doubt, the first solution over here is definitely very, very bad. I think that this solution right here is definitely a pain in the rear because we are making a change to our config file. And anytime that we're changing our config file, we would probably want to do a git commit, right? We would probably want to commit that new version. Well, the downside to wanting to do that git commit is that, remember, we traditionally only build our versions with or build our images with the docker build command right here when we are in a CI environment, like off on Travis CI. And so we're only on Travis CI when we've already made a git commit. So we're kind of talking about like making a git commit to update the image and then pushing this off to Travis, getting the image built right here, and then simultaneously taking that version number and updating this file and then committing this file too at the same time while we're still on Travis. Now, if that doesn't make sense, that's totally fine. What I'm trying to say is that this step right here, it definitely sounds like it's a good solution, but in practice, it ends up being a tremendous pain in the rear. So that kind of leaves us with solution 3 over here. We're going to use an imperative command. So after we rebuild an image, we are going to tag it with a version number. And then we're going to very specifically reach out to kubectl and tell it to update our deployment with the latest version of the image that we just pushed up to Docker Hub. Now, I know this uses an imperative command, and I just told you how we like to avoid these as much as possible. But again, this is kind of like the best of a bad situation. And I think that you'll see when we eventually deploy our application to a production environment, this ends up being like a pretty reasonable solution. It's not the best solution, but it's pretty reasonable when it really comes down to it. Ooh, okay, so this has been a very long section. I apologize for the length, but again, I wanted to make sure it's really clear that this is just a continuous, not nice issue to have to deal with, and I wanted to go over some of these possible solutions because these 3 in particular get outlined in this issue thread over here if you decide to read this thing. All right, so with all that in mind, let's take a quick pause right here. We're going to come back to the next section. We're going to learn how we can somehow tag our image with a unique version number when we build it, and then make sure that we can run a command that's going to tell our deployment to update itself with the latest version number available. So quick pause, and we'll come back in the next section.